On the last video, we create this test bench file for repro carry adder. We analyze and synthesize it. And when we analyze and synthesize, we didn't put the test bench file as top level entity. We didn't do that. We keep the original file that we want to test as a top level entity. So that's how it should be. And then when analyze society, we make sure we didn't get any errors here. Even warnings, we can look. Okay, we can see you have a warning here. So this first warning, we can all set up the global variable to use all the process to make the simulation faster. But here, this maybe it will cause some error on our simulation. So we need to fix this error here. We can see here it created a net implement for the carry out, because you can see this it's been spelling wrong. So we need to find this carry out. So we are missing the y here. So it should be carry out, test bench carry out. So we can go and launch our ModelSim. So we can simulate on the ModelSim. Now we're here on the ModelSim, so we can compile our file. So compile. So we need to compile the test bench file and the original model. We are compiling them. And then we go to work and simulate the test bench file. And then we can add the waves to the, and then we can toggle the leaf name so we get all the names. So here we have our carry in, our x, y, and sum. So now we need to simulate all the scenario, all the input scenarios that we had. So if we look at our test bench file here, our x's and y, so it runs, the simulation runs out up to 2560 nanoseconds. Now where we can do it, we can simulate the first 15, every 15 numbers, the first 15 combinations. So that one is going to be 160 nanoseconds. And try to run the simulation. So, and then we can change the inputs to unsigned, so we can see all the numbers. So you can see here in the transcript we have from x is from 1 to 15, and the y is 0. And if you go to the wave here, we can see the exact thing. Let me zoom it out a bit. So you can see, for example, on the x, you see the 1 here, 1. So you have 1, 2. So you have 1 here, 0, 1, 2, 3. So this is how we create those square waves, which each one with different period. So you can see as is shown this wave simulation. And then when you add that one, x and y every time is 0 on this, the first 160 nanoseconds. So this is the answer you'll get, 15. So like 15 plus 0 is 15. So let's simulate 160 nanoseconds again. So you're going to be 320. So you can see here now, this one was 15 plus 0. Now y is 1. For example, 0 plus 1 It's all, so you have 2, 3, and then you can, here is interesting, you can see you have 14 plus 1 is 15, and 15 plus 1 is 16, should be 16, but it shows 0 because this is 4-bit, and then we must have a carry out. And then you can see here the carry out, the signals is on the carry out. So for example, if you're not familiar with square wave, or you cannot document your work on the square wave, you can always print it out to the transcript. So the way you can do it, you can go back to your test bench file and add here, for example, carry. So you can carry out. And then you can, let me make sure I'm doing the things correctly. And then you need to add, this is equal to a percent 0D, so it's 1 bit. Save it. Now here you don't need to like compile again. You have saved it. You can go to library here, and then you can update, and then you can recompile, and then you can restart the simulation. And run. So you can see here we have carry out is shown up, and we can one more time. You can see here 15 plus 1. It says 0, but we have a carry out. I know we know the carry out is in 5th position, so that is 16. So this is how you will simulate it. So if you can simulate all of it now, simulate all. No. To the last, so you can see you have 15 plus 15, so it's 14 plus 16 is 30. So this is how you can see if in our the last time we did it on the, we explain it, the same thing we have here. So this, when it is larger than 15, the carry out is displayed on the display board, on this carry out bit. So this is how you will design your ripple carry adder, and how you design your test bench file and simulate. So on the next video we're gonna continue with this design, but now we're gonna subtract x and x minus y, for example.